What's going on, everyone? Welcome back to Axiom. In today's video, we are tackling virtual memory, and honestly, this is a game changer for your operating system's preparation. Pay close attention because this will definitely come up in your exams. Here we go. Every single day, billions of us use the internet without even thinking about this silent, invisible system that makes it all possible. It's called DNS, and it's basically the magic that turns the website names we type into the numbers computers actually need to work. So let's dive in and demystify the internet's most critical and honestly most overlooked piece of infrastructure. Seriously, think about it for a second. You type a name into your browser, hit enter, and boom, the website just appears. It feels instantaneous, right? But what's really happening in that split second is this incredibly sophisticated high speed journey across the globe. We're going to pull back the curtain on that whole process. At its core, the idea is actually pretty simple. DNS is often called the phone book of the internet, and that's a great analogy. Just like you would look up a friend's name to find their number, DNS looks up a website's name to find its unique IP address. I mean, can you imagine if we had to memorize long strings of numbers for every single site we wanted to visit? No, thank you. Okay, but here's where that simple phone book idea starts to fall apart. A single phone book for the entire planet, it would just collapse under the weight of all those requests. It's impossible. So, how does DNS handle this insane scale and speed? Well, the secret is all in how it asks for information. To really get this, we have to understand that the system uses two totally different ways of asking questions or queries to find an answer. Think of it like this: it's the difference between hiring a detective and saying, solve this case for me, versus just asking a bunch of people one by one for the next clue. So let's look at the two types. On one side, you've got the recursive query. This is what your computer sends out. It's pretty demanding. It basically says, look, I don't care how you get it, just bring me back the final IP address. I'll be right here waiting. But then behind the scenes, you have the iterative query. This is how the DNS servers talk to each other. It's way more collaborative. It's like asking, hey, I'm looking for this thing. You got it? No? Okay. Well, who should I ask next? All right. So let's actually follow the journey of one of these queries. Your computer has made its demanding recursive request. And now a special server called the DNS resolver has to go on this little hunt using those iterative clue finding queries to track down the answer. Okay, so here's how it goes down. Your computer asks the resolver for the answer. The resolver probably doesn't know it, so first it asks a root server. These are like the ultimate directories for the internet. The root server says, I don't have the final answer, but I know who handles all the .com addresses. Go talk to them. That's clue number one. So the resolver then goes and asks the .com server. That server says, nope, not me, but I know the exact server that's in charge of the specific website you want. Clue number two. Finally, the resolver makes one last trip, asks that authoritative server, and that server gives it the final IP address. The resolver then zips back and gives that answer to your computer. And this really captures the whole process perfectly. Your computer makes one simple request, but the resolver, our detective, does all the heavy lifting. It's hopping from server to server, gathering clues until it finally cracks the case and gets that IP address. But even this amazing process would be way too slow if it happened for every single request. And that's where DNS's real secret weapon comes in. And that secret weapon is caching. It's all about how DNS remembers answers. It's already found so it doesn't have to play detective every single time. And just as importantly, it's about how it forgets. I mean, this quote from Scout DNS just nails it. Caching isn't some add on or nice little optimization. It is a fundamental design choice for the entire system. Without it, the internet as we know it would grind to a halt. It just couldn't work. So, how does it work? Well, every answer that DNS provides comes with a little expiration date attached to it, called the time to live or TTL. Now, this is where a lot of people get confused. The TTL doesn't mean the server has to use the answer for that long. It means it's the maximum time it's allowed to use it. It's a ceiling, not a requirement. Another key thing to remember is that resolvers are super specific about what they cache. They don't just remember example.com. They cache the specific answer to a specific question. So they'll cache the A record. That's your standard website IP address, or the AA record for the newer IPv6 addresses. If you're sending an email, they'll cache the MX record, which points to the mail server. And get this, they even cache negative answers. So if a domain doesn't exist, they'll remember that too, which saves a ton of time on lookups that are just going to fail anyway. Pretty smart right now? This whole system of caching and TTLs is what makes TNS so fast and so resilient, but it also creates a famous trade off. It's the reason why when you make a change to a website, it doesn't just instantly appear for everyone on the planet. And this is the perfect real world example. So, a website owner changes their server's IP address. Some people who visit the site will get the new one right away. Why? Because their DNS resolver hadn't cached the old one, but other people will keep getting sent to the old address. The difference isn't some magical propagation speed, it all comes down to one thing: how long those old answers are allowed to live in caches around the world before their TTL expires, and this is the part that can feel a little weird. You've got different people getting different answers at the same time, but that's not a bug, it's a feature. The system was designed this way on purpose. DNS trades away instant global updates in exchange for unbelievable scale and resilience. It allows every resolver to have its own local memory, which keeps the whole system from getting overwhelmed. I just love this summary from Scout DNS because it gets to the heart of it so perfectly. The default setting for the entire internet is to remember. Forgetting is an active process that is deliberately controlled by time. So we end up with this really big question: the internet we all use was built on a system that shows stability and massive scale over being instantly up to date. But today we are moving towards a web that demands more and more real time, and that's everything you need to know about virtual memory. If this video helped you understand the concept better, make sure to hit that like button and drop a comment below telling me which topic you want me to cover next. Don't forget to subscribe to Axiom and turn on the bell icon so you never miss a new lecture. See you in the next one.